In today's class, we're going to be discussing what mass is, and then what weight is, and the last thing we'll discuss will be the differences between mass and weight. So, if you are ready, let's begin properly now. So, what is mass? Mass is one of the fundamental quantities we have in physics. We have 7 of them, and mass is one of them. And mass is constrained by both length, breadth, and height. So mass is the amount of substance or the amount of matter in an object. The amount of matter in an object is termed to be mass. For example, you can see this body here weighing 2 kilograms, and then we have an apple here. And you can see that this balance is well balanced at equilibrium state. Is because this apple is also termed to be 2 kilograms. So the amount of matter in this apple is 2 kilograms, while the amount of matter in this mass, this object, is 2 kilograms. Even though this is an edible material or fruit termed as object, this is not edible. But you can see that what makes up this object and what makes up this object are termed as matter, and they are weighing 2 kilograms each. So it is constant everywhere. Mass is constant everywhere. It does not change with location. Anywhere you take this apple to, either in Nigeria, in UK, in US, any country at all, this apple will remain as 2 kg, or this object will remain as 2 kg wherever you take this object to. But the only difference here is this: when you consider weight, then there will be little changes to this particular value. Hence, it is measured using a balance. You can use balance to measure mass. This is the instrument that is basically used in measuring mass. The SI unit is the kilogram. That's the SI unit. We have other units that can be used in measuring mass, but basically the standard unit recognized globally is the kilogram. So you should know, based on vector and scalar, that mass is a scalar quantity. Okay, it is measured in kilogram. It is independent of gravity. It is independent of gravity, and it remains the same on the earth. It remains the same on the moon. It remains the same on any planet. Mass is the real deal. Now, measuring mass. Mass is measured using a balance. For example, if I have 1 kilogram of an object by the left hand side, now I will need, if I'm breaking 1 kilogram down into 2, then I will need 2 500-gram masses at the right hand side to balance this particular equation. Hence, the kilogram is the SI unit, but we have other units such as grams, and then we have milligram, and then we have the ton. These are other units used in measuring masses. Now, in conversion, you should know that when converting mass, the SI units of masses from one SI unit to another, these are what you must take note of. 1 kilogram will give you 1000 grams. Okay, and 1000 grams will give you 1 kilogram. Then 1 gram will give you 100 milligram, and 100 milligram will give you 1 gram. And then 1 ton will give you 1000 kilogram, and 1000 kilogram will give you 1 ton. And then 1 milligram will equal 0.01 gram, and then 0.01 grams will give you 1 milligram, and then 1 gram will equal 0.01 kilogram. Understand this concept and understand mass. For example, the mass of a book is 0.5 kilogram. The mass of an apple is 150 grams. The mass of a person can be 60 kilograms or more. The mass of a car can be 1200 kilograms. Are you getting the SI unit here? So take note of all this. Then, for mass versus weight, the key differences, which I'm going to go deep into later, you should understand that there are key differences between mass and weight, but I'll capture that as we continue. Now, what is your formula for mass? Mass is given as total mass divided by the number of objects, where m is the mass of one object, the capital M is the total mass in kilogram, and the small letter n is the number of objects. In real life example, we have 2 kilograms of rice. Okay, we can have 55 kilograms weighing of a person. If you climb your weighing scale, then your bag, your school bag, can weigh 1.2 kilograms, and then a watermelon can weigh 500 grams. So remember that mass is what an object has. Alright, mass is what an object has, and mass does not change with location. Take note of this. Now I'm giving you classwork simply quickly. Now solve this and drop it in the comments. Challenge question: a stone has mass of 250 grams. What is its mass in kilogram? So you are expected to convert this, and then you drop your answer in the comments. Let's proceed to weight now. What is weight? Now, weight is the force exerted on an object by gravity. Weight is the force exerted on an object by gravity. This object here, alright, the object you are seeing, the object is the mass. Okay, because object contains mass. So it's just like saying weight is a force exerted on a body with mass by gravity. That is it. So let's assume that this is an apple. Remember the apple I showed you earlier. You can see that if this apple is in space, it can be drawn towards the earth from wherever it is in space. So the weight of an object acts at its center of gravity. The weight acts at the center of gravity towards the center of the earth. So everything has to do with the center of that particular object. So key points: weight is a vector quantity, while mass is a scalar quantity. It acts vertically downwards. It acts vertically downwards. That is for weight. Weight acts vertically downward. You should understand this particular aspect. Then it depends on gravitational field, which is small letter g. Okay, and then it is 0 in free space where there is no gravity. While on the moon, weight is less than on the earth. Take note of this particular part. One key thing you must know is that weight is the force with which the earth or any other planet attracts an object. So without it, planets cannot attract an object to themselves. Then it acts vertically downward towards the center of the earth. Key thing you must note: it changes from place to place. Weight changes from place to place because gravitational pull changes according to your location on the earth. Now it means that your weight in London can be different from your weight in the United States, and your weight in Nigeria can be different from your weight in Ghana. Yes, because it differs, it changes from place to place. It is measured in Newton, which is capital letter N. Take note of this because weight is the same thing as force. Alright, now if I'm having weight, we need an instrument that can be used in measuring this weight, and that is where we have the spring balance. We can use the spring balance to measure weight, and you can see our object hanging on the spring. So the reading on the scale gives the weight in Newton. What is our formula for weight? If you are asked to calculate the weight of an object, then you will need the mass of the object multiplied by the constant acceleration due to gravity. You will need that in order to calculate for the weight of that particular object. If that is the case, then we should know that weight is W, then mass is m in kilogram, then g is acceleration due to gravity, and it is 10 or 9.8 meters per second squared on the earth. That is the value of the constant. Now sometimes it is approximated to be 10 Newton per kilogram used for calculations. So take note of this. If you're asked to find mass, you can divide weight by acceleration due to gravity to obtain mass. Alright, so that is that for this. What are the factors affecting weight? factors that affect weight today include the mass. Weight increases as mass increases. Alright? Weight will increase when mass increases. Then gravity affects weight. Weight increases as gravity increases. Weight will also increase. Then what affects weight again is the location, your position on the earth. Weight varies from place to place. So mass remains constant everywhere, but weight changes drastically with your position on the earth. So imagine I have this question. A book has a mass of 2 kilograms. Its weight on earth is, our formula is weight equals mass times acceleration due to gravity, and our mass is 2 kilograms. So you multiply that by your constant, which is 9.8, and to give us 19.6 Newton. Or if we say a boy has a mass of 40 kilograms, his weight on earth will now equal 40 multiplied by 9.8, which will give us 392 Newton. Or if it is a stone that is weighing 3 kilograms, the weight on the moon can be W equals mg, which is 3 times 1.6, which will give us 4.8. Yes. Take note of this typical example. For the constant g on the moon, we can say 1.6 Newton per kilogram. If you are given this constant, then you can use it to multiply your formula, and you can solve for what you need to solve, and you get what you need to get. Many students think that weight and mass are the same, but remember that mass is constant while weight is not. So remember, weight depends on where you are. That is why you feel lighter on the moon as you move to space. So this is your classwork exercise. You drop your answers in the comments. A man has a mass of 60 kilograms. What is his weight on earth? What is his weight on the moon? Use G for earth to be 9.8 Newton per kilogram, and then 1.6 Newton per kilogram on the moon. So I need this answer to be dropped in the comment section down below. So finally, what are the differences between mass and weight? You should know that mass is an object, or the amount of matter in an object, but weight is a force which gravity pulls on an object. This is one difference that you can get between mass and weight. The second difference is that mass is constant everywhere, but weight changes from place to place. Then the third difference, mass is measured in kilogram, while weight is measured in Newton. Take note of all this. So mass versus weight. Alright, by definition, amount of matter in an object is mass, while force exerted on an object by gravity is weight. The second is by nature. Scalar quantity, it has no direction, while weight is a vector quantity because it has direction. The third difference is by what it depends on, and mass does not depend on location, but weight depends on the gravitational field strength on the earth. Then we also have another difference that we can talk about based on this is change with location. Mass does not change from place to place, but weight changes from place to place. What about SI unit? Weight is measured in Newton, but mass is measured in kilogram. And by measurement, weight is measured using a spring balance, the instrument, while mass is measured using a balance based on instrument. Then by formula, mass has no formula per se, but weight has a particular and specific formula. So key points you must note are what I've just described to you. So mass tells you how much matter is in an object, but weight tells you how strongly gravity pulls that object. Then on the moon, your mass stays the same, but your weight becomes less. In space, which there is no gravity, weight is zero, but mass remains the same. So that is the analogy between these two. Take note of our formula, which is very important, the differences, and the SI units. take note of this. I've captured this for you, and based on the instrument we use in measuring mass and what we use in measuring weight, and then the relationship here, you can see that if mass increases, weight will increase. If gravity increases, weight will increase. If gravity decreases, weight will also decrease. Look at the question here based on conversion. A boy has a mass of 50 kilograms. What is his weight on the earth? We know that W equals mg. So our m is 50 multiplied by 9.8 gives you 490 Newton. A girl has a mass of 40 kilograms. If G on the moon is 1.6 Newton per kilogram, what is her weight on the moon? We know that our formula is W equals mg. So W equals 40 multiplied by 1.6, and to give you 64 Newton. What about if I have a stone that has a mass of 2 kilograms? What is its weight in space? Now we know that our G is 0, so weight equals 2 multiplied by 0, and everything remains 0. So take note of all these particular values and you will understand the concept perfectly. Remember that I'm giving you another exercise to solve. Solve this question quickly. A man has a mass of 70 kilograms. What is his weight on Jupiter? Use G for Jupiter to be 24.8 Newton per kilogram. Drop your answer in the comments. I hope to see you in my next episode. Peace.